we're gonna see, I think, can you see the pointer in the screen for the ones that are here? The ones that are online probably can do it, but yeah, cool, awesome. We're gonna do an intro to FastAPI and some tips and tricks for machine learning. But before that, I want to know, because I have too much content. I have like, I don't know, 2.5 talks, and I have half an hour to give that. So I'm gonna be running through one of the parts of all the content I have. How many of you have heard of FastAPI before? Cool, a few of you. How many of you have used FastAPI even a little bit before? Okay, cool. So I see that there's a bunch of people that have used it. It might be a little bit boring for you. For the other ones, I'm gonna give like a quick intro to FastAPI so that not everything is super confusing. First, I'm Sebastian Ramirez. I am from Colombia in South America. That's why the accent. But I live in Berlin, Germany. I'm PyData, and the organization brought me here for the talk today. You can find me online on these places. I created FastAPI and a bunch of other open source projects. So about FastAPI. FastAPI is a framework, a web API framework for building the thing that will run on a server. So the web API is the thing that you will use to create the component in the server that other things will communicate to. So the browser, mobile application, desktop applications, or other services could communicate to your backend that is providing the API using FastAPI. Now, a little bit about FastAPI. This graph shows like the GitHub stars, so it's been growing a bit per month. FastAPI is the red line, Flask is the blue line, and Django is the yellow line. This is actually a little bit updated because these two are gonna cross in the next 5 days or so, which is fun. Now, if you add Rails here, which is this pink line, you can see that it's very cool to be working in Python because it's been growing a lot. So that's fun. It's been growing and it's been getting like some adoption, which I didn't expect, but that's very cool. It's also have been getting a bunch of downloads monthly and like, and it's the fastest growing web framework in Python. Actually, the only one that is growing. And it's been like also in showing up in like the other developer servers like Stack Overflow. At some point, it was like here. Now it's like on top of Svelte and Ruby on Rails, and then like AngularJS and stuff like that, which is super cool. And like this survey mixes front end and back end, so it's like I don't know, I guess a nice achievement. Internet points, yay! Internet points. So there's a bunch of companies that use FastAPI. You might recognize one or two here. It's also used by things like the web space. I don't know if you recognize this picture that was popular recently. It was taken by the Web Space Telescope. So the institute that handles that information got like all the science data and distributed to the scientists around the world using FastAPI. It's also used in a bunch of places inside of OpenAI. You can see like the open source repos and stuff use FastAPI. Their official demos for building ChatGPT plugins and stuff use FastAPI. It was also used in the supercomputers in Carnegie Mellon to in something that resulted in a successful James Webb Telescope proposal to observe the first quasar in the first observing cycle. I have no idea what that means, but it sounds very cool. So nice, exciting. It's also used to control the particle accelerators, including the Large Hadron Collider at CERN. So if at some point you see like a black hole in Switzerland, maybe create an issue in the GitHub because it might be my fault. I don't think I will be able to fix it on time, but we can try. I don't know. Again, like very cool, exciting. It's also going to power the next generation of Jupyter. You probably have heard of Jupyter if you are doing data. So there's a bunch of companies and things that are using FastAPI. This is just to kind of argument why it will make sense to even be interested in FastAPI for those that have not used it or heard of it. Now, let's see FastAPI code. FastAPI is easy and short. That is the idea. So you import from FastAPI, you import the FastAPI class, then you create an object that is an instance of this class, and then you use this to decorate a function. To decorate is to put it with this @ symbol. This is telling, hey, FastAPI, I want you to do your thing with this function that is here below. And your thing in this case is going to be whenever someone sends a request that goes to /, so the root is just /, and the request is using HTTP GET, I want you to use this function to handle that request. And then we are just returning a dictionary, and FastAPI will make sure that it's converted to JSON and is sent as JSON to the client. So this is a fully functioning web API. The idea is that the more FastAPI code that you write, the less API code that you write. So you can focus on the business logic and like the important things about your application, and not on dealing with like, all the nonsense of APIs. The idea is to try to get out of the way. Now let's build a little bit more complex of an API. Let me go back for a second. So this is an async function because FastAPI underneath is an async framework. Now let's continue forward. This is a non-async function. This is a regular function because FastAPI can do the smart thing and make sure that everything works underneath. For those that like the technical details, it will run it on a thread worker in a thread pool, so it doesn't block the event loop in the main thread. If you didn't understand that, don't worry. I don't understand that like fully, so it's fine. The thing is that it will do the smart thing so that you get like the best performance that you can get while you keep the code that you already have. Now, let's look at this one. We are creating another path operation function or another endpoint. And whenever someone goes to /items/ and this item ID, you can see that it has these curly braces as if it was an F string, but we don't have the F here because this is not actually a variable. This is like the template format, but it's the same format as with F strings. So it should be kind of memorable. We are telling it, hey, this is going to be a path parameter. So this could be variable in the URL. So it will be something like this. Let's say that the API is at somedomain.com. If we go to /items/5, then this number 5, FastAPI will know that it has to extract it from here, and then it will put it in this parameter, item ID. And we are telling Python, the code, we are telling, hey, item ID is going to be of type integer. So FastAPI is going to read, this is the standard syntax that you will use in Python to say, this is the type of this parameter. FastAPI will use this information to extract this here and convert it to an actual integer. So what you receive here is not going to be a string, even though this comes from a long string. A URL is just a string. A URL doesn't have types, but FastAPI will make sure that, to see that, like, okay, this thing is declared as an integer, so I'm going to convert it to an integer and I'm going to give you an integer. So you get the data in the types and the shapes that you define here in the parameters. We also have Q, which is a string, and by default, this is none. Because it has a default, then it's not required. And because Q is not part of the query of the path here, then it's going to be extracted from the query parameters. The query parameters are those that go after the question mark. So after the question mark, you will have a bunch of key value pairs. So you will have a name like Q, and then equals, and then the value, some query. So Q, this parameter here in this function, whenever someone calls it in this URL, this Q parameter is going to have the value some query. Now, if you go to /docs, with that same code that I showed you, if you go to /docs, you get this automatic user interface to interact with your API live that is generated from your code. You don't have to do anything else to get this. And we can see that we have /items/item ID, and item ID is an integer that goes in the path parameters. This is required because this comes from the path. And we also have Q, which is a string, and this comes from the query parameters. So it knows what are the types that we expect, we are expected to send in the API. So an integer and a string, and it shows the documentation automatically. So you write some basic code, and good guy FastAPI makes a docs user interface for you. Now, let's build a FastAPI app with a body. We want to define what is the shape of the JSON body that we want to receive. So now we want to receive data. So now we're declaring a post request. So HTTP post. And now we're going to receive, what we are going to do is that we are going to import from Pydantic, we import a base model. FastAPI is built on top of two tools. One is Starlet. It does all the web parts, and you normally don't interact with it directly because FastAPI does that. The other one is Pydantic that does all the data parts. Data validation, serialization, documentation. That one you interact with directly. So we import from Pydantic, we import a base model, then we create a class that inherits from this class. And then we define what is the shape of the data that we want to have. So we say name is going to be a string, ingredients is going to be a list of strings that by default is an empty list. Because it has a default, then this one is not going to be required. But this one doesn't have a default, so this is going to be required. Again, this is just the standard type annotations for Python. This is not something that you import from FastAPI or Pydantic. This is just like the standard way that you do it. If you are in Python 3.9 or above, you can actually use the standard list instead of importing from typing import list. And now we use this class, we put it in the parameters here. And again, this is the standard Python syntax for saying this parameter food is going to be an instance of the class food. FastAPI will make sure that this is what you receive. So you're going to be able to access the attributes and everything inside of the function here. And if you go to the docs, to the same docs user interface, now we can see that we have this post endpoint that goes to /food, and it also knows what is the shape of the data that we expect to receive. A name that is a string, and ingredients is a list of strings. So this is documentation that is generated automatically, not only for the FastAPI parts, but for your data parts. So you define your data however you want it to, however you want to receive it, and then you get the documentation for that data automatically. And you can actually, let me go back for a second. If you click this button, try it out, then you get this interface. This is all happening in the browser from your API that you're developing, like, as you develop it. And then you can actually interact with your API. You can send a request, you can click execute, and you're going to get the response back, and you're going to see it here. This is coming directly from the API that you are developing live. So this can help a lot quick iterations. And then, well, let me go for a second. Let me show you. We are sending a request with a food item called empanadas. And the ingredients are harina, carne, arroz, and sabrosura. So you can be happy as this cat with empanadas. That was I was ruining the joke, but yeah, anyway. Now, let's say that we want to define a body and a query parameter. So we say food is going to be an instance of the class food, and delivery is going to be a Boolean that by default is false, because this one is a scalar value. So this is not a pedantic model or something like that. Then FastAPI is going to extract it from the query parameters, and then food is going to be extracted from the body parameters. So you just put the parameters in the signature in the function that you define, and then FastAPI extracts the data from the request using those parameters. And if you go to the docs again, this is how you will use this new path operation or this new endpoint. You will go to /food/, you will send a post request with some JSON data, and you will say, hey, question mark, here's the query parameter, delivery equals true. And now, because we defined that it was of type Boolean, FastAPI will know that the only valid values are going to be true or false. So the automatic user interface is going to show you, hey, the options are true or false. That's it. That's all you can send. So again, you get like automatic data documentation for your API. You don't have to put everything in the body. You can put things in query parameters when it makes sense. Now, let's say that we want to have a JSON array of JSON objects in the body. So this is equivalent to a list of dictionaries. Then again, we just use standard type annotations. We are no longer saying like, this is just a food item that is an instance of food. Now this is a list of instances of the class food. And FastAPI will make sure this is what you received. So you can iterate for each one of the food items in this list of orders, and then for each ingredient in each one of the food items, food.ingredients, and then you can just like work with that, like, because you're gonna have the shape, the data that you defined that you were expecting. And if you go to the docs, again, automatically generated from the shape of the data that you define. Now this is a list of dictionaries or a JSON array of JSON objects, depending on the terminology that you're using, but the same thing. So if you want to have JSON and you want to have it inside of JSON, you can just do that. You can define any complex, arbitrarily nested data structures that you want just with standard type annotations, and FastAPI will do the rest for you. Now, what happens if you send invalid data? And this is the key part. So this thing here, this is actually valid JSON. It's not that it has like an extra comma at the end or something like that. So this is valid JSON, but the data doesn't conform to what we defined that we were expecting. Let's see how. So the first item, name, it's a taco. This is a string, that's fine. Ingredients is a list of strings. Frijoles, carne, taco shell, and sabrosura. So this is fine because it's a list of strings. Now the second item, name is a string, is pizza. This one doesn't have ingredients, but we say that ingredients have a default value, so ingredients is not required. Now the next item, Trojan food is a string. This is fine. Ingredients is a list that as a first item, it has a string. Then the next item is actually a JSON object or like a dictionary, which is a sneaky object. So this is not valid. This thing inside of the ingredients is not valid. And then the last one has a food name that is all bread, but it doesn't have name. It has food name. So this one is also not valid because it doesn't have the required field name. If we try to execute this, FastAPI will tell the client, hey, you are sending invalid data. But it not only tells the data is invalid, it tells the client exactly how and where the data is invalid. So we can see that inside of the body in orders at index 2, so the third item, inside of ingredients at index 1, so the second item, a string type was expected, but we were sending a sneaky object, not a string. And in the body in orders at index 3, the name field was required. And we didn't send a name field, we sent a food name or something like that. So when we send invalid data, FastAPI will protect your code from executing with invalid objects with invalid data. But when you send valid data, when the client sends valid data, FastAPI and the code that you define will just like work as you defined it with the types. So if the types are correct, then everything is going to work. FastAPI will make sure that what you get is like valid data. And because this is all based on standard Python type annotations, you get autocompletion everywhere in the code. So here we are in a double nested for loop, and still we get autocompletion for each one of the ingredients because it knows that each ingredient is part of food.ingredients, and food.ingredients is part of all the orders, and each, like all the orders is a list of this class food. So it knows that each one of these ingredients is each one of these strings in this list of strings that comes from ingredients. So, you just define the type annotations in the right place, and then the autocompletion and everything just like trickles down everywhere inside of your code. So you get autocompletion everywhere. This is me coding when I have autocompletion. This could be you. Now, we also get type checks. If we try to sum a string with an integer, we get an error telling us, hey, you are having like some error here. This will explode. And because we have it here, we can fix it before we commit and before we push that change. So it won't explode in the server at 3 a.m. and then you get like woken up at 3 a.m. because the server is exploding. You can just like fix it before committing, and then you can claim that you're a 10x engineer or something like that because you never made the mistake. You never committed the bug. And this is all based on standard Python types. So FastAPI is based on standards. OpenAPI, which internally uses JSON schema and also uses Auth2 for authentication and authorization. And because all these standards, we get the automatic API docs, which is this thing that is provided by another open source library called Swagger UI, which uses the standards. The thing is, you don't need to know about those, but by using FastAPI, you're building something that is already built on standards. So you get something based on standards. And because it's based on standard type hints, you don't have to learn something new. It's just like the standard Python. And FastAPI will do automatic data validation and data conversion, automatically using Pydantic. So it's all based on standards for free. Now, about the performance, this is a benchmark run by Tech Empower, which is a third party that runs benchmarks of a bunch of different languages and frameworks and stuff. I'm only showing you Golang, which is a compiled language, and Python. Go is the green lines, Python is the blue lines. Of course, Go has to be faster because Go is a compiled language. And still, with FastAPI and a couple of others here, managed to be on the ballpark of like, the range of like even a little bit better than some of the Go frameworks. You get on the ballpark of the best that you can get in Python, which is quite nice. Which one of these ones is the fastest is not super clear because this one below Ubicorn, this is not a framework. This is actually a server that is running everything here. So Ubicorn should be on top of everything. So you get some random noise here, but the thing is you get on the ballpark of the best that you can get. And in this case, FastAPI was being able, in this particular benchmark with this particular machine this was run or whatever, FastAPI was being able to handle 15,000 requests per second, which is nice because it's over 9,000. Some other features, there's dependency injection, security with auth, WebSockets files, background tasks, easy GraphQL integration, templates, like everything that you will expect from one of these frameworks. But like, of course, it will shine the most when you are building web APIs. Now let's see, how are we with time? How are we with time? Cool. Just like, let me know when I have to stop. Because now we're getting to the stuff. Okay, bye. No, now we're getting to the machine learning stuff. I wanted to give you, because there's a few people that didn't know that much about FastAPI, so I wanted to give you a like slowish paced introduction to FastAPI. Now we're going to the machine learning stuff. So this might have to be a little bit faster, but anyway. So in machine learning, you will have, I won't teach you anything about machine learning. You know that stuff better than me. But there are some things that will like happen in any machine learning that you are doing. You're going to have some type of model, some function that will load some expensive model that will, in this case, this will just return a function. So imagine that loading this was like something super slow. And it's just going to return a function that you can use to do inference and generate some outcome, some prediction. So this line, load expensive model, this will be super slow running. Whenever you run this code, this will be the one that will be super slow. Imagine that. This line running the actual inference will not be that as slow as loading models, because this is the one that has to read from disk and like load all the weights and all the stuff. Now, the main trick is read from disk as few times as possible. Because if you are reading a bunch of weights, gigabytes of weights from disk, and you are reading those gigabytes of weights every time you're trying to run one single inference, then every time you're trying to run one single inference is going to be super slow. So that is the main trick. And the question is like, is this an ML trip or just like a coding tip? Then it's kind of coding. But the thing is that this applies a lot to machine learning because you are loading a lot of data from disk very frequently. Now, let's just remove the thing that was running the inference below, and let's just like keep this simple function because we are going to use this function in a FastAPI application. This is the simplest thing that you can do, and this is good. So you have a file that imports the machine learning model, the load expensive model, and then you load that model at the top of the file. Model equals load expensive model. This line is going to be slow. So whenever you start your application, it's going to take a while because it's loading the model. So this is going to be slow. But then when it's calling the requests, this part is going to be fast because the model is already loaded. That is fine. That's okay. That's the first approach, and that is good. The thing is, maybe you start doing like tests or something, or maybe you have like other code here, and you don't want to have to be waiting every time for the model to load. So, maybe it's taking too long the first time it's just started, and you don't want it to take a long time just loading the model. So maybe you say like, let's load the model inside of the function, so that just starting this thing doesn't get so much time. It's not as slow. But then this is bad because this means that every time you're handling one single request, this is going to load the model from disk. So every time a user tries to get your request, it's going to take seconds just loading the thing from disk. So this might be a lot faster for testing, for running one single test, but it's actually terrible performance for your application. So just don't do this. Now, this is something else you can do that is worse, which is we have some internal stuff, and then we are loading the model here. And then you can also load it in different places. So first, we process internal stuff, and this loads the model. Second, we process internal stuff again, and this again loads the model. And then later, we also load the model directly here. And finally, we just run some inference or whatever. But the thing is, we are running this thing, load expensive model. We are executing this line many times per request. So this is terrible. This is super slow. Just don't do this. You're going to kill your servers, and your manager is not going to like it. So yeah, just download the model multiple times per request, because this is the phase that you will have at 4 a.m. when you're trying to debug the server. Now, here's the trick. You can use the same function, the same everything, but you can import from functools. Functools comes from Python. You don't have to install anything to have this. And then you can import an ALRU cache. ALRU cache is like a very fancy name, and it sounds like, this is so academical, but it's not really. ALRU means least recently used. You don't even need to know that, because you don't need to know the details that much. You just call this function on top of the function that you are calling. What this is going to do is that whenever you call the function load expensive model cached, this one, the first time you execute it, is going to execute and it's going to return a value. The next time that you execute the same function, instead of executing all this code, it's going to return the same value that it had already generated. So in this point, when you are loading the PyTorch model or whatever, this is going to load from disk a bunch of weights, and it's going to take a long time, and it's going to return that model here. But the next time that you call this function, load expensive model cached, instead of reading again from disk, it's just going to return the same value that it returned the first time that you called it. So now, all of a sudden, and actually, this cache is based on the parameters of this function. So you could have like, I don't know, one model per client or something, one model per customer, something like that. and it will still work. It will not return the model, like one model for one customer and then the same model for another customer. No, if you have the customer ID here, then it will return like whatever is the model that's like correlated to whichever customer you are dealing with. And now suddenly all the stuff that was bad before now just works. Process internal stuff, we can call it many times, because this load expensive model cache is going to be slow only the first time that you call it. The first time we call first for the first request, and this is going to be slow, but then it loads the model, returns the model. Second, it's going to load everything. Whenever this is called, it's going to return the same model, so it's not going to be expensive. And then we call this model load expensive model again for a third time, and it's going to use the same value, so it's not going to be slow. And for the next request that comes, this was already loaded, so the next request is going to be super fast. Only the first request ever, when you start the server, for the first time this is executed, is going to be slow. So now like all the problems are solved just by using a cache. So you don't have to refactor everything, just using that little trick of a cache, and that can save a lot of work. Now, you might not want to have the first request to be super slow. So maybe one trick that you can do is, for example, if you're deploying this to Kubernetes or something like that, you can have like some health checks or something that are triggered automatically by Kubernetes or the stuff that you have in place that could check that everything is ready. And then inside of the health check, you can load the expensive model. This will take a while, but then the model is already cached. And once this returns, hey, I'm ready to receive requests, then this function was already called for the first time. So the first request that is handled by this application is going to be super fast. So you could load the model at the top level, and that is fine. Or you could use a cache. Or you could use a cache and preload at startup if you want to be like super fancy. But if you are not sure, just load the model at the first level. Don't load the model inside of a function if you are not doing anything else to make sure that it's not reading from disk every time. Again, this is the same trick as at the beginning. Read from disk as few times as possible. Now, don't use async. FastAPI is an async framework, and you might have heard like, oh, async, this is going to be just so much performance. Let's put everything async, and that's it. No, that's not how it works. For async to work, you need to have like the stuff internally to also be compatible with async. So if something is slow, if something is taking a while, it has to be compatible with async, and you have to be able to put a wait on front of that. If you can't, then you should not do this. So this line might be slow because maybe it's a huge model, and then running inference it just takes like half a second. That's a lot. If you put this inside of async, this means that one request is going to block the entire process, so no other request will be handled while this inference is being run. So just don't do this. Because you will be trying to optimize performance, putting async away, but then you end up putting blocking code inside of async, and this is just blocking everything. So the trick is just don't put blocking code directly in async functions. The simplest thing you can do is just don't use async, and that's going to give you like pretty much the best you can do until you have to optimize things. But at first, just don't use async. Like that will be the simplest thing. Just use regular def functions, and you will be fine for a long while. Like you will have to optimize async def long after you are customers paying you. If you don't have paying customers yet, you probably don't need to optimize with async. So I don't need to handle all the async stuff. You just don't use async stuff. That is the simplest way to handle async stuff. Now, if you really need to use async, but you need to handle stuff that is blocking, then you can use asyncer, and from asyncer you could import asyncify. The thing is that you need to be able to call await inside of the async functions when you're calling stuff that is slow. Asyncify is going to take whatever is the thing that will be blocking and will make it something awaitable, something that you can put await in front. So this means that it will not hold the whole process without being able to handle other requests. So it will actually run it on a thread worker underneath. So you will be able to keep handling other requests. And then this asyncify is going to return a function that you can actually await, and that function is going to receive the parameters, whatever were the parameters that this original thing will be receiving. So whenever you have something that is blocking, like this model that could be blocking, and you need to use async, then you can use asyncify and put whatever is that function or that callable that will be slow inside of it, and then you can just await for that. Now, Asyncify had an asyncer, unlike disclaimer, Asyncer is a library that I built. It's built on top of a couple of other libraries, but that's a whole talk. But the thing is that it has all the type annotations and all the tricks underneath, so you will get auto-completion internally, even for the variables that you define in your original function. So the model will receive an X parameter. This thing that we put Asyncify inside of the model, this is also going to receive the X parameter, and it's going to give you auto-completion for that as well. And it's also gonna give you inline errors and all the stuff. So if you don't pass the required parameters, it's also gonna tell you, hey, this you are calling this this call is invalid because you are not passing the required parameters. And of course, it also has like inline errors for the types of the data shapes that you define. So if X was supposed to be an integer, then you cannot pass, or a float, you cannot pass something that is a string. So you get like, still, you get like all the inline errors, auto-completion, all that stuff. Now, if you want to run concurrent calls, you don't want to be calling one function await, then the next function await, and then the next function await, because that means that you are just like running one after the other. Then like you are actually not doing anything concurrently. If you need to call, for example, you need to call 3 machine learning APIs and then collect all the results and then return them back, but they don't depend on the previous one, then what you can do is with Asyncer, you can create a task group. I'm not going to give you like a lot of the details because I'm probably running short of time. But then you do task group.sunify, and then this sunify is going to take a function. Sunify means that it's going to make it something that will be called soon. It's not going to call it yet at this line, but it's going to call it soon. So you tell it what is the function that you want this to sunify, and then you pass the parameters that it will receive. So in this case, is this fetch inference that receives a remote URL and some parameters. So now here you pass remote URL and you pass some parameters. This is going to return something that is a soon value. So it's not yet a value, but soon it will be. Whenever you are out of this block with async, so async with blah, 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 whenever you are out of this, now all these soon values will have an attribute dot value that will have the actual value that you were expecting. The thing is, this async with block is the thing that is going to make sure that everything is run concurrently. So you are not waiting for one API to finish before you are calling the next API. You're going to be able to do everything during the same period of time. So you can have like a much lower latency for this particular call. And then you can just like return these 3 values that are extracted from the soon values. And now you suddenly have like concurrency. And of course, this has like all the same internal type annotations and tricks and stuff. So you will get auto-completion even when you are soonifying functions. And you get like the auto-completion for the data that you receive. So each one of these values, it knows that each one of the values will be of, the type will be a dictionary of strings of with keys of strings and floats as values. So it knows that value 1 that is extracted from one of these soon values, this has like all the auto-completion for dictionaries. So it knows what is the final data that you get back at the end. And now like you can do a bunch of concurrent stuff during the same period of time. Now, what happens if you need to call something that is blocking? Like this function is blocking, and we're going to call this function, and we can want to call this function that is blocking. We want to call it concurrently. Now, if we put that in Sunify, Sunify only receives async functions, not blocking functions. So we're going to see an error. Hey, this thing is not async. Like you're making some mistake here. So dang it. Only if we could have a way to make this function something that is awaitable. So then we can come again back to Asyncify, and then we can just Sunify, and inside of that we can say, hey, I want to Sunify this thing that I want to Asyncify, and now you can call the whole thing. So now you can concurrently call code that is blocking and use like all the magic stuff of async and await inside of a code base that is otherwise all fully blocking. But you get like all the concurrency and all that stuff and all these benefits. And again, because Asyncify and Sunify and all these things have like all the correct types and stuff internally, you get auto-completion and you get all the inline errors and all the stuff. And now you can say that you know async. How are we in time? Are we fine? It's time. Do you want questions or do you want to hear more rambling? Who wants the questions? Hands up. No one has questions. Okay, one question. I can repeat the question. So for those online that don't know what's happening, I ran out of time, and we're gonna see one question that is online, and then we're gonna continue rambling a little bit more. What is the question? So the question is if FastAPI needs any payment for building. Yeah. I'm just repeating it because I guess that the live stream doesn't hear you. Okay. Well, they see the question on the live stream. I was thinking about the other people seeing the live stream. So FastAPI doesn't need like any. FastAPI is MIT license, so you can do whatever you want with it. It's just like free. It's open source. I guess that was the question. Now let's keep rambling a little bit more, and now this gets a little bit more sophisticated. So let's see. With FastAPI, you can have dependencies. Dependencies is just this thing, like depends. It's a way to tell FastAPI, hey, I want you to call this function for me. And the function here, getModel, is going to be this function, getModel. And this getModel might just do something like return the load expensive model cached. And then when we do this, FastAPI will make sure that this parameter model is going to receive the result of this dependency. So everything is pretty much the same. We can do the same things that we were doing with the model, but now FastAPI is running it for us. Why will it be useful? Now we're going to see why. In particular, for testing. For testing, you might not want to be calling some expensive LLM API just for running tests. So you might want to override this function, and instead of getting the actual model or getting the actual, like, calling an external API or something like that, you could be using this fake function that will replace that data. And then FastAPI will make sure that it, when during the tests or during this section, when we are overriding this dependency, it's going to use this different function to return that. But all the rest of the code would just like work the same. If this sounds weird, modeling dependencies for overrides in tests, like, don't worry too much about it. Like, you will end up at that whenever you need it. Don't try to over-engineer your stuff. Don't try to use it if you don't know that you really need it yet. Now, if you want to squeeze performance, because normally, for example, a model will return something like a NumPy ND array or something like that, or tensor. It's still an array in my heart. But then you can actually, instead of FastAPI, FastAPI will convert that automatically to JSON and will return that automatically. But it will do like all the serialization and all the stuff, and that could be expensive because FastAPI has to guess what is the shape of the data that you're returning, what is the types of the data that you're returning, and it's just gonna do everything it can to convert it to JSON. But if you know ahead of time how to convert that to JSON, you can just directly return a JSON response, or even better, an ORJSON response. ORJSON uses ORJSON is a library, and an ORJSON response is a response that uses the library. And ORJSON is a library that is kind of a drop-in replacement for the standard Python JSON library, but it's just written in Rust, so has much better performance. And then you can just like return this directly. Nevertheless, now Pydantic was the core of Pydantic, which is the tool that does all the data stuff internally, was rewritten. The core was rewritten in Rust. So now you get like all that amazing performance if you upgrade your version of FastAPI and your version of Pydantic. And soon Pydantic will do the serialization of JSON. So in most of the cases, this won't even be necessary, and you will just like get crazy performance like for free. But in any case, because like Pydantic was rewritten in Rust, and like this is a way to return something that serializes stuff in Rust, it comes the question like, have you considered rewriting in Rust? Because that's the fad, But anyway, and yeah, well, that's what I have for you. Thank you very much. Maybe we can do some questions now. Thank you. Do we have time for questions, or
we can do maybe one or two questions and then we're good?
Good. We have one question here.
I want to comment first of all. We have I'm from H&M, and we have put FastAPI in production usage with hundreds of models, more than 5 models in daisy chain environment. So we know what you're talking about, performance tuning.
Nice.
Thank you very much.
Nice. I'm glad to hear that. And I'm glad that it's not exploding. Nice. That's amazing. Thank you.
But how do you see that now that we have these models are being coming out of the cloud vendors, but there are also other platforms? where does FastAPI stand in competition compared to these managed services?
So depending on the types of models and depending on how you are distributing your models, how many models you have, how frequently you're retraining or things like that, depending on that and like cost savings and things, in some cases it might be cheaper to host models in some of these cloud services, but normally they don't give you like, all the other API layer on top, like all the authentication and all the serialization, all the stuff. So some common use cases to have like this model serving provided by some other thing and then FastAPI in the middle to connect with that. But I have also heard like a bunch of people say that whenever you want to have the best performance, you normally load the model in the same container that you are serving FastAPI. It's not necessarily too intuitive because these model serving things are like very high performance and are in many cases written in like, I don't know, C++ or something like that. But still, the network, like the network overhead sometimes is just like bad enough that it's just better to load the model directly in the same container of your FastAPI application. But it will probably be just like, like case by case decision. What I have heard is if you want to have like the best performance, then just like everything inside of FastAPI. And I mean, what I have heard, because like there's a lot of other people doing so much more model deployments than what I do myself directly, and like what I've heard from a bunch of other people. But like it might be more expensive than if you use like one of these services. So I guess it's like, yeah, you have just to benchmark your own application and like see what works better. Yeah. Do you have more questions?
All right.
There's one question
We
at
can
the
do
end.
one. If you have a quick one, we can do it. Otherwise, no, I'm just joking.
Hi, I'm Tasin. I have two questions actually. The first one is, how do you suggest to handle situations where it is reading values from the cache, but in the meantime, the values in the disk get updated? So that's my first question. And the second question is, do I get the slides after the session? Like, will you share it anywhere?
Yes. So first, the second question. I will share the slides later. Just like remind me on Twitter or LinkedIn or something, because I will forget. But then like remind me later, and of course I will share them.
Yep.
Now, if you are loading the models in the cache, like like you will just like code the thing to make sure that you are not doing that. What you can do is store the state of the models in something like Redis or something like that, and then you can like to know what was the last time that it was loaded. Then you will probably have to implement some type of caching that also has some tag of when was the cache loaded. Or for example, whenever you're returning something from this function that has the alert cache on top, maybe you're not returning just the model, but the model also has some flag, some attribute or something that says what is the timestamp of the moment where this was loaded. And then you can compare that whenever you are using it, comparing to the timestamp that you have in Redis or some in-memory database that was set from whatever was the other thing that saved the models somewhere else, so that you know that you are actually having something that is still consistent. What you can do is have the alert cache thing, store the timestamp, and then wrap that in another function that is the one that is checking Redis and checking what is the timestamp of this thing. And if the thing is invalid, then you invalidate that, reload, and then serve it. But then like this wrapper will be like the equivalent of the load model. But
Thank you.
yeah, of course.
Okay.
I think that's it.
Yes.
Yeah. Thank you very
So-
much. I'm also gonna be like around, so like if you have more questions here later, like we
Yes.
can just like chat.
I was about to say, Sebastian will be around if you have questions. Now we will have a short break until like 10 past so that you can use the bathroom, chat a bit, do all the good stuff. And then we will be back for our second talk.
Thank you. Thank you.